In this video, I answer questions 1 through 5 from the 2022 specimen paper. I also review on each question general physics topics such as common estimation values, SI-based units, homogeneous equations, scalars and vectors quantities, and vertical motion upwards. Question 1. A student creates a table to show reasonable estimates of some physical quantities. Which row is not a reasonable estimate? This question is about estimation. And here is a table with some estimated values. My suggestion is that you memorize these values. You make it easier to answer this type of questions. So let me look option A. Electric current in a fan heater, 12 amps. So here in this table, it shows that a typical current in domestic appliance is 13 amps. So option A is correct. Option B, mass of an adult person. So here is another table with some estimated values. And it shows the mass of a person is 70 kilograms. So option B is also correct. Option C, the maximum speed of an Olympic sprint runner, 10 meters per second. To answer this question, we need to know the estimated sprint time is 10 seconds. For a race of 100 meters, so the velocity will be 100 meters divided by 10 seconds. So the velocity is 10 meters per second. So option C is also correct. Option D, water pressure at the bottom of a garden pond, 10 to the 6 pascals. To answer this question, let's imagine a pond as this picture is showing. So the pressure at sea level is 1 times 10 to the 5 Pascal. So this is the atmospheric pressure. The total pressure at the bottom of this pond is the atmospheric pressure plus the pressure of the fluid, which is this rho is the density of water, g is the acceleration of gravity, and delta h is the height or the depth of this pond. Let's imagine a typical pond 2 meters deep. And how we are going to calculate this? So the pressure at the bottom of this pond will be the density of water, which is 1000 times 9.8, which is g, times the height or depth, which is 2. So the pressure at the bottom is 19,600 pascals, which is approximately, I want to convert these into 10 to the power. So 1 times 10 to the 4 pascals, if I kind of round this number. Now, to find the total pressure at the bottom, you be the pressure, atmospheric pressure plus the pressure of the liquid. So 10 to the 5 plus 10 to the 4th. So the result will be in the range of 10 to the 5 Pascal. So this value here is a little bit too high compared with the estimated value. So the option D is not a reasonable estimate. So this answer will be incorrect. Question 2. Which expression has the same SI base units as pressure? To answer this question, we have to look the two formulas that we have for pressure. One is pressure in fluids, which is the density of the fluid times acceleration of gravity, which is 9.81 meters per second square, times the height. And the pressure in solids is the weight or the force perpendicular to the cross-sectional area where the force is being applied. Now, to answer this question, we have to look the way the options are. It's not showing in SI base units. It's showing in terms of force, length, time. So let's see how we can get this. So I'm using the formula for pressure in solids. If you decide to try pressure in fluids, we should get the same answer. But for simplicity of the explanation, I'm using the formula for pressure in solids. So let's go. Pressure in solids is the weight over area. The weight formula is mass times gravity in area. Now, gravity is meter per second square. So meter is length, second square is time square. And area is width times length, which is 2 times the length of any object. So length is square. So now we have, I'm going to cancel length with length. So I will have just one length on the denominator. So it's math over length times time square. Option C. Question 3. The speed V of a liquid leaving a tube depends on the change in pressure, delta P, and the density rho of the liquid. The speed is given by the equation. Here is the equation. V is equal K. This is a fraction. The change in pressure over density. All these with the n power. Where K is a constant that has no units, what is the value of n? So this is a typical question related to homogeneous equations. And what is homogeneous equations? Is when the base units on either side of the equation are the same. So this table shows the SI base units used in physics. So we are going to look here: length, meter, mass in kilograms, time in seconds, current ampere, temperature in Kelvin, and this last one, amount of substance, mole, we don't use that much. So now let's see how to answer this question. For simplicity of my explanation, I'm using the formula for pressure in terms of force over area. However, if you decide to use the formula for pressure of a liquid, which is rho g h, density times acceleration of gravity times height, you have the same answer. Let me start by doing some units substitution here. Velocity is meters per second. Pressure is force over area. So force is Newton, area is square meter. And we have here density on the denominator, so I will keep as it is. So times 1 over density. Now K, I'm not going to use in my answer because K has no units. Is irrelevant. Okay, keep going here with the program. Newton is kilograms, which is mass times acceleration. So mass is kilograms, acceleration is meters per second square. And also I did a substitution for density, which is mass over volume. Mass is kilograms, volume is cubic meter. In this next step, I'm showing that I flip the fraction related to density. This is 1 over this fraction. I just flip to make it easier to cancel all the variables. So here, as you see, I cancel kilograms with kilograms, and I simplify the m's, the meters, so I have just left meter square over second square. So the question here, now we stop and you think, what will be the value of n, this exponent right here, to make this a homogeneous equation, which means meters per second equal to meters per second. Let's have some thoughts. Here are some options. So let me start with half and see how it goes. So let's make n is equal half. All right, so what happened here is, if I do exponent n, which is half, and half, so then the result will be m over s, because 2 times half is 1. So I don't even have to go farther with the other options, because this here will give me the right answer. So A. Question 4. Which row correctly describes the quantities momentum, power, and temperature in terms of scalars and vectors? So here is a list of scalar quantities: distance, speed, energy, time, mass, density, electric current, pressure, temperature, volume, area, and please add power is missing. The next table, we have some 5 vector quantities: displacement, velocity, and acceleration. All 3 are part of motion. And then we have momentum and force. Here is a hint for your exam. Questions about scalar and vectors are usually straightforward. Memorize both lists of scalar and vector quantities. It will make it way easier for you to answer the question, but please add power in this scalar quantities list because it's missing here. So let's go back to the answer, to the question. Question 4. So momentum is a vector. Power is not listed here, but is a scalar. And temperature is listed and is a scalar. So the answer is C. Last question, number 5. A girl throws a ball vertically upwards. It takes a time of 3.2 seconds to return to her hand. Assume air resistance is negligible. What is the initial speed with which the ball is thrown? So let me do a quick diagram here. So here is the ball. The ball is being thrown upward. And when it reaches its maximum height, it's going to stop. and then it's going to shift motion and it's gonna come down and back to her hand. So this up and down, we have a distance d, vertical distance. And to answer this question, let me set up everything in a table that I'm going to call vertical upward motion. And remember, because the ball decelerates as it goes upward. So let's make g, the acceleration g, negative. Acceleration in this case a will be equal acceleration of gravity, which is 9.81 meters per second square. Okay, so let me organize everything in the table with all the values. So the vertical upward motion, VI, is the initial velocity we are looking for. VF going up, so it's going to stop right here. So it's going to be 0. D, the distance or height, the vertical one. Acceleration, negative 9.81 meters per second square. The time going up is the total time divided by 2. To answer this question, we need an equation. So this equation is the simplest one to use. Final velocity is equal initial velocity plus AT. Final velocity is 0. VI is the variable that we are looking at. Acceleration is negative 9.81 times 3.2 divided by 2. And here we have VI minus 15.68. So VI is 15.68 meters per second. That's the initial velocity. And the answer is C.